Hello friends, I am Nitin Arya, and in this session we will discuss mean and variance of normal distribution. So here it is the PDF of normal distribution. We have already seen fx is given by 1 upon sigma root of 2 pi e raised to the power minus 1 by 2 x minus mu upon sigma whole square. The next varies from minus infinite to infinite. The first we move to mean. As you know, x is a normal variate. Then mean of x is defined as expected value of x, and expected value, definition of expected value for continuous random variable is minus infinite to infinite x fx dx, integral minus infinite to infinite x fx dx. Which is equal to 1 upon sigma root 2 pi integral minus infinite to infinite x e raised to the power minus 1 by 2 x minus mu upon sigma whole square dx. That is the value of fx. Let us substitute z equal to x minus mu upon sigma to simplify the integral. Dz equal to 1 upon sigma dx, and x becomes z into sigma plus mu. And substituting these values in the integral, we have x will become mu plus sigma z e raised to the power minus z square by 2 dx becomes sigma dz, and the integral, we will get these two integrals. One is minus infinite to infinite e to the power minus z square dz, and another is minus infinite to infinite z e to the power minus z square by 2 dz. Let us take I1, first integral I1, and second integral assume I2. I1 is minus infinite to infinite e to the power minus z square by 2 dz mu 1 upon root 2 pi. As we know that fz equal to this is probability density function of standard normal variate z, and integral minus infinite to infinite fz dz equal to 1. So this integral will become mu as 1 upon root 2 pi integral minus infinite to infinite e to the power minus z square by 2 dz becomes 1. Similarly, for this integral, this is an odd function of z, that's why this integral will become 0, and expected value of x is mu. That means mean of the normal distribution is mu. Now let us move to variance. X is normal variate, then variance of x is defined as expected value of x minus mu ka whole square, right? Then by the definition of expected value, whole square of x minus mu into fx, and whole integral minus infinite to infinite. Again, substitute the value of fx, and to simplify the integral, let us substitute x minus mu upon sigma equal to z equal to x minus mu upon sigma, then dz equal to same 1 upon sigma dx, and x equal to mu plus sigma dz. So substituting these value in the above integral, we will get 1 upon sigma root 2 pi minus infinite to infinite whole square of sigma z e to the power minus z square by 2 sigma dz. Sigma will be cancelled out, and this will be the form of integral minus infinite to infinite z square e to the power minus z square by 2 dz. As there are one algebraic function and one exponential function having negative power, we can convert this integral into gamma integral by appropriate substitution. So let us substitute z square by 2 equal to t. this is z dz equal to dt, and the whole integral will become 0 to infinite t to the power half e to the power minus t dt, which is t to the power 3 by 2 minus 1 e to the power minus t dt, which is nothing but gamma 3 by 2, because gamma n is integral 0 to infinite t to the power n minus 1 e to the power minus t dt. So integral 3 by 2 will become gamma half plus 1, that is half gamma half. Gamma half is root pi, and 2 cancel, root pi cancel, and this become sigma square. So variance of x is nothing but sigma square. So if z is a standard normal variate, we have already calculated the mean and variance for the normal variate x. Mean is mu and variance is sigma square. Now we are considering the standard normal variate z, which is x minus mu upon sigma. The expected value of z, that is mean of z, is expected value of x minus mu upon sigma. Sigma, by the property of expected value, we will take out the sigma. Expected value of x minus mu, that is ex minus e of mu. E of mu is nothing but mu, and ex is also mu, then this will become 0. So mean of the standard normal variate z is 0, and variance x minus mu upon sigma, sigma square will come out. Variance of x minus mu, that is variance of x minus variance of mu, variance of constant is 0, that is variance of x is sigma square. Sigma square by sigma square is 1, so variance of standard normal variate is 1. So we can conclude that x is normally distributed with parameter mu and sigma square, or with mean mu and variance sigma square, and z is normally distributed with mean 0 and variance 1. Thank you.